Hello again and good morning. Today we are solving question 1171. Remove zero-sum consecutive nodes from linked list. Given the head of a linked list, we repeatedly delete consecutive sequences of nodes that sum up to 0 until there are no such sequences. After doing so, return the head of the final linked list. You may return any such answer. Note that in the examples below, all sequences are serializations of list node objects. Okay, so in order to solve this question, we need to use the idea of prefix sum. So example, we have a 0 prefix sum before we start. And as we continue onto the list, it will be 1, and then 3, and then 0. So the pattern is that we land on a 0 prefix sum, and that is a sum that we've seen before, which is when we started. So that tells us that there are a 0-sum consecutive node. That means we could delete these. And that is the basis of the solution. So we want to use a dictionary to store pointers of sum to node. We want to do one pass through the linked list and calculate the prefix sum of all nodes. So here is the idea, right? So we have a dictionary and we're going to start it off at 0. The 0 prefix sum pointing at the beginning of the list, right? We'll call it dummy. So we'll start with dummy node that comes before head. And it will be 0, and it will point to dummy. And then when we get to over here, it will be 0, but it would point to -3. So essentially, it would replace the 0 that we have already. So instead of 0 dummy, it would be 0 -3 node. So when it replaces the dictionary key after the first pass, in our second pass, we could take all respective, we could how can I explain this? So in our second pass, we're going to start at 0 again. And right now 0 is at dummy. But in our dictionary from the first pass, we could see that 0 no longer points to dummy. It actually points to -3. So in this case, all we have to do is to reassign current nodes next to dictionaries nodes next, if that makes sense. And the solution would be in O of n time, because we do a pass through the linked list. Even though we do it twice, it's still going to be O of n. So let's solve this. Dictionary 0 dummy equals list node 0. So we have a dummy node, which is just a random node 0, and we assign it before the head, so it So dummy.next equals head, so that means it comes before the head. And then we initialize our dictionary where 0 prefix sum is dummy, and then we'll do prefix equals 0. Or for it to make more sense, it would be like this. Prefix dummy, like that. And then we could do while head prefix plus equals head.val. So we're going to add the value. So prefix is now 1. And then we have to add this to the dictionary. So 1 is now assigned to the current node. And then we have to move forward. So now when we get to 2, prefix would become 3, and then 3 would point to the 2. Okay, so this, we're done with the first pass. Now our second pass is reassign current nodes next to dictionary nodes next. So while head, we'll just start all over in while head. While head prefix plus equals. I think we need to reassign prefix. Prefix equals 0. Head.val. Hang on, so let's check this out. Let's redo this over here. So 1 is equal to this, 3 is equal to this, 6 is equal to this, 3 is equal to this. And we saw 3. 3 was right here. 3, 6, 3. So this has a 3 and this has a 3. So that means this dot next should be this dot next. And this one is a 1. So this dot next equals this dot next. Okay. So while head prefix plus equals head.val head.next equals as such. Then we can return dummy.next. Okay, we need to test this. I am not too sure about this. Okay, we need to start from dummy, so head equals dummy. And then that should work. Okay. Yeah, because we can't start from head because that would mean there would be no point in using dummy because we use dummy to start from, we put dummy before head and dummy has a prefix sum of 0. So if we ever run into a prefix sum of 0, we have to replace everything in between. So like, let's say we had a 0 here, right? Because that's the dummy node. And let's just say all of this stuff add up to 0. When we get to here, we have to remove everything in between. And if we start from head, this cannot be done. That's why we have to start from dummy. And then that's why we have to start from dummy at the second scan, so we can remove everything in between. Thank you for watching. This has been the Daily LeetCode Challenge. Peace out.